I want to record this little bit. It's going to be part of another video on derivative of inverse function. So what I have here is wired, and at the point 1, right, slope right there, right, is 1. You go up 1, 2. Slope should look like that, right? 2 of the tangent line, right? I didn't draw that really well, but all right, now the inverse function, first of all, right, we're going to go from y to x instead of, we have two choices, right? We have, like say 4, we have the positive square root of 4, which is 2. We also have the negative square root of 4, which is minus 2. So there's possible functions here, right? And you have to pick one. So be careful with that when you're doing trigonometric functions, because you have to pick one and you have to restrict the domain. Notice that if x is a function of y, y is only defined for positive numbers. Well, 0, non-negative numbers, right? So let this positive part of the graph and look at its inverse function, right? So that basically means we're going to replace x by y and y by x. And so what that means is, as it says in the book, page 130 something, 36, is you just interchange them, right? You want to see that again? And so I'm going to flip, I'm going to interchange the x and the y, right? Go back, interchange the x and the y. Looks like that. So interchange the x and the y, flip them over, all right? Reflect around x line, that. Now, here's that point, that same point, but now the goal is 1, and the horizontal part of the triangle, so that says that rise is 1, 2, right? So when you go over 2, you're going to go up 1. So what does that tell you? Well, here, the slope is 2. Flip it over, the slope is 1/2. Make sense to you? All right. Now, when you're doing, be aware that you arrange for this inverse function to exist. I also have to talk about exponential and logarithms, but I'll do on my iPad.